In the mid-20th century, computers were not the sleek, handheld devices we know today. They were massive, room-sized monoliths of vacuum tubes, wires, and mechanical relays. They were slow, temperamental, and entirely inaccessible to anyone who wasn't a mathematical prodigy or an electrical engineer. Programming one meant manually flipping switches or laboriously writing in complex numerical code. It was a tedious, error-prone process that felt more like mechanical engineering than creative problem-solving. One woman saw this reality and decided that if computers were going to truly change the world, they needed to be taught to speak a language that people actually understood. Her name was Grace Hopper, and she would go on to become the architect of modern programming. This is the story of the woman who didn't just code, she revolutionized the way we talk to machines. Grace Hopper was born in New York City in 1906. From an early age, she possessed an insatiable curiosity, famously dismantling 7 alarm clocks to understand their inner workings before her mother finally put a stop to it. She earned her PhD in mathematics from Yale by 1934 and spent years teaching at Vassar College. But when World War II began, she felt a call to serve. At 34, she was initially rejected by the Navy for being too old and too thin, but she persisted, eventually securing a waiver and joining the Waves, women accepted for voluntary emergency service. In 1944, she was assigned to the Harvard Computation Lab, working on the Harvard Mark I, one of the world's first large-scale automated calculators. In this era, the programmers were often women who had to manually translate mathematical equations into the machine's complex command sequences. Hopper, however, didn't just want to operate the machine. She wanted to understand how to optimize the entire process of human-to-computer communication. After the war, Hopper joined the Eckert-Mauchly Computer Corporation, the team behind the UNIVAC QI, the first commercial electronic computer. It was here that she proposed something radical. Computers should be able to understand English. Her colleagues were skeptical, telling her that computers were for arithmetic, not for linguistic processing. They argued that machines couldn't possibly understand human words. Hopper disagreed. She envisioned a future where a programmer could write a command like subtract income tax from pay, and the computer would handle the heavy lifting of converting that into the binary machine code it understood. By 1952, she had developed the A0 system, an operational link loader, the precursor to what we now call a compiler. While the industry largely ignored her at first, Hopper continued to refine the technology. She moved from mathematical symbols to creating languages like Flowmatic, which used English-based commands. This work wasn't just an improvement, it was the foundation for machine-independent programming, effectively decoupling the software from the specific hardware it ran on. One of the most famous stories in computer science involves Grace Hopper and a moth. In 1947, while working on the Harvard Mark II, her team encountered a persistent error in the machine. Upon investigation, they discovered a moth trapped in one of the computer's physical relays, causing the system to malfunction. They removed the insect and taped it into the project logbook with the note, "First actual case of bug being found." While the term bug had been used to describe mechanical faults for decades, going back to inventors like Thomas Edison, this incident became legendary. It wasn't the first time an error was called a bug, and it is widely believed the entry wasn't even written by Hopper herself. Yet, the story stuck, and Hopper became the figurehead who popularized the term debugging within the context of computer science. It was a testament to her career. She was the one who turned a technical frustration into a cultural icon of the industry. By the late 1950s, Hopper's vision for English-based programming led to the development of COBOL, or Common Business-Oriented Language. As a consultant to the committee that defined the language, Hopper championed the idea that code should be readable and accessible. COBOL became the standard for data processing across the government and private sector, a role it maintains in many systems to this day. Hopper didn't stop there. She remained an active duty officer, eventually reaching the rank of Rear Admiral. She spent her later years at Digital Equipment Corporation, acting as both a consultant and a goodwill ambassador for the future of computing. She became famous for her lectures, where she would hand out pieces of wire exactly 11.8 inches long to explain the concept of a nanosecond, the distance light travels in that time, to help people understand why speed and size mattered so much in computing. When she passed away in 1992, she left behind a field that had been fundamentally transformed by her insistence that technology should be designed for the user, not just the engineer. Her career proved that the biggest barrier to progress isn't the machine itself, but our own willingness to cling to the way things have always been done. She taught a generation that if you want to change the world, you have to be willing to try it. If you enjoyed this video, subscribe for similar ones.